Hello, welcome to today's screencast. Focus is on forces within biomechanics. So as you can see, specification is requiring you to understand net force, balanced force, unbalanced force. Now before we go on to net force, balanced forces and unbalanced forces, what we need to do is have an understanding of those forces which make up or will make a force balanced or unbalanced. So we need to look at the emboldened forces here, weight, reaction, friction, air resistance, and then we're also going to have a look at the factors affecting friction and air resistance, and then we're going to have a look at actually how we draw free body diagrams with regard to different sporting actions. So if we go on from here then, first things first, let's get our scene set for today's lesson. Now depending on where you are in your scheme of work at the moment, you will have some understanding of the fact that a force is a push or pull that alters a body's state of motion. Okay, we will also, some people may know that force equals mass times acceleration and can be measured in newtons. They might be things you already know. What we have to know today, is we have to kind of, I suppose, really delve into four specific types of forces, and these forces are known as external forces. Okay, so how these forces act on a performer can dictate a number of things which are really interesting for us as sports people, and also for us when we want to do well in the A-level P exam. So if we go down from here then, I'm going to put this as a diagram that we're going to build into as we go through, so you can see how these external forces act on the human body. So first things first then, we're going to need to split our four external forces into vertical and horizontal forces. Starting off, vertical forces then means the force is going to travel up or down. So the first one we're going to have a look at is weight, okay? And weight refers to the gravitational pull exerted by the earth. So as you can see, the arrow here is being pulled downwards, so it's a downwards arrow because it's coming from the centre of mass here, and the force is the gravitational pull from the earth, so it's going down this way. Okay, the second force we're going to have a look at is reaction force. Now, those who have studied Newton's third law of action-reaction will have some understanding of this. So in terms of the reaction force, what we have to have an understanding of is as follows. A reaction force is the equal and opposite force exerted by a body in response to the action force placed upon it. So in this case, action force has gone down by the foot to the floor, and then the reaction force is then coming back up from the foot, from the floor to the foot, and it's going upwards. So it would start at the floor on the foot, and then it will come back up this way. So the reaction force, the arrow would need to come this way, as you can see there. Now on top of that, they are our two vertical forces. What we need to have a look at now are our horizontal forces. Okay, so let's have a look at horizontal. So it means that they're going to travel left or right, depending on which way your performer or the direction of travel. As you can see here, I've labelled the direction of travel going this way. So let's have a look at these then. First one we have to look at then is friction. Now, friction is an example of an opposition force. So basically, it's a force that opposes motion of two surfaces in contact. So what you can see here, if it's an opposition force, so if you have a look at friction, now friction, the arrow should maybe just be a little bit back there. If you can see here, it's traveling. Now, the reason why friction, the arrow goes this way, is if you imagine now that the athlete here is running, he's running that way, but when he presses down, the direction of his foot or his leg is going back that way. Okay, so because it's going back that way, okay, the friction force opposes the two surfaces in contact. So because it's going back that way, okay, we then have our friction force coming this way because it opposes the motion. Okay, so that is why it goes in that direction, and it will always be in the direction of travel, well, for specific things which we'll have a look at when we go into examples in a second. And if we go on from there, the second horizontal force we have to have a look at is air resistance, which basically is the force that opposes motion through the air. Okay, so if we have a look at this one, it's going to start at our center of mass and it goes backwards. Okay, so you can see that if you're running this way, the faster you run, the bigger this arrow might go in terms of air resistance. So it opposes the motion through the air. Okay, so it's an opposition force. Okay, same as we looked at with friction, but in this case, when you're going this way, the air resistance comes back the opposite way. Okay, so what is important, okay, at this point? Now, we're going to look at each force in isolation, so don't worry too much at the moment. What I just wanted to say to start with is this. If you get into a situation in an exam, okay, you might be asked to draw a force, okay, a free body diagram. So if that is the case, what I need you to make sure you can do is something to just keep in your mind. Whenever you're drawing a force, please make sure you identify or you start at a set point, okay, and then you put very clearly the direction in which it's traveling. Okay, so for example, if you were doing here, if we had a look at a reaction force, you know, when you're drawing it, you need to make sure you start it at the right place. In this case, it will be the floor and the foot, where the floor and the foot are making contact. Okay, and then we've got the reaction force coming back up this way. Okay, so that's very clear because I'll put the arrow there, the direction of it. Okay, when I'm drawing air resistance, I need to start it at the right point, which needs to be the center of mass. And the center of mass, then the arrow direction needs to be going backwards because it opposes motion through the air. Okay, so you can see it there. So that is just making sure that you get that right. Now, it's obviously anybody who's slapdash when doing these type of answers with regard to the start point, the direction in which it's going, will get themselves into trouble and won't get marks. So please take that into account, and I'll keep reminding you of that as we go through each one. So now what we need to do then is isolate each force and have a look at it in action. So if we start off then, like I said before, you can start to make good notes at this point. So vertical force type we're going to go for then is weight. Okay, so as we said, weight refers to the gravitational pull exerted by the earth on a body. Okay, so if you say it onto there, measured in newtons, if you want to add that, you can. If we go on from there then, in terms of how you work out weight, which you will have done or will do when you look at the calculations within biomechanics, it's measured in newtons, but in order to work out weight, it's mass. Okay, so the mass of the human body in this case times acceleration due to gravity, so the speed at which it's pulled down towards the earth. Okay, so that is how we measure weight. So you need to make sure you have this definition: gravitational pull exerted by the earth on a body. Now, what do we need to do next? Next thing we need to have a look at is this. Okay, so when we are drawing it, make sure now you're making good notes on this, that you have accurate, you can describe this accurately, or you could draw it accurately. So in this case, the start point, center of mass there, please make sure you're drawing these accurately, and then the direction it's traveling, obviously because it's a gravitational pull from the earth, it's going down to the floor, not halfway up, down to the floor. Okay, always in the direction of travel at the bottom. Okay, so that's that one complete. So if we go on to our next vertical force then. So our next vertical force is reaction. Okay, so a reaction force, as I said before, when you're talking about a reaction force, it's the equal and opposite force exerted by a body in response, in reaction to the action placed on it. Okay, and when we've got this, you know, it can also be measured in newtons. We're not so bothered about that for now. So if we've got that on there, that is the key section. So if you want to add this to it, this is just something to keep in. It is the result of Newton's third law. Okay, and whenever two bodies are in contact, foot and the floor, floor and the foot, okay, it will always happen. This force will always take place. So really important by that. And you know, it's a case of the bigger the action force placed by the foot to the floor, the bigger the reaction force placed by the floor to the foot, which causes a bigger acceleration or jumping upwards. If it was, say, for example, a basketballer doing a layup or a high jumper. Okay, so if that's our section there, in terms of making sure we draw it correctly, we must make sure that our start point is the foot on the floor. Okay, and we're somewhere around that point, so we can get it to foot to the floor, and the direction it's traveling is upwards. Okay, so that's that section complete. Now, if we move on from here, let's have a look at our next one. So now we are looking at our horizontal forces, and we're going to start off with looking at the horizontal force of friction. Okay, so friction refers to the force that opposes the motion of two surfaces in contact, foot and floor. Okay, so in this case, the friction force, as you can see onto here, well, let's go back so you can see here. So I've said here, so force that opposes the motion of two surfaces in contact. So I've said to you, the leg, when it goes down here, the action of the leg will go back round this way. okay, when you're running. So friction opposes when these two surfaces come into contact. Okay, so the friction will go forward, the leg goes backwards, the direction of travel is forwards as well. Okay, so you can see that is for friction, not forwards. Okay, but it's a good way to help you remember when drawing the friction one here. Now it also applies to cyclists. Okay, so when you think of a cyclist, I haven't got a pen with me at the moment. So if I said when you say for example direction of travel, same as here, but you've got a bike with tyres on. If you imagine if I just draw my imaginary tyre here, when you think about it, when you're going that way, the tyre goes backwards. Okay, so the friction force acts forward, exactly the same process as it does with a running leg. Okay, so the foot is in contact with the floor is in contact with the foot, but friction opposes the motion there. So if we can get that right, hopefully you can see how that works. Now what we have to do, we've got our basics here, definition. What we need to do now is have an understanding, which is really, really important. People in sport are trying to get friction. Friction can really aid our performance. So what we need to understand, and you need to know, is what factors then affect friction. So, I'm sorry, before I go on to that, if you just want to just make sure you've got your drawing and describing the force, so you've got the start point, okay, foot on the floor, direction of travel, same as the direction of travel there. So as I said, sorry, I forgot about that animation. If we have a look down to here then, what factors affect how much friction we can get? So if you are a sprinter, an athlete, okay, so a 100-meter sprinter, what factors might you take into consideration with regard to where you could increase the friction that you get? So let's start off with then. The first factor affecting friction we're going to have a look at is the roughness of the ground. Okay, so for example, for a sprinter in this situation, the roughness of the ground might refer to athletics track being rough, which will increase friction. Okay, so you can think of the surface when you're on an athletics track, rough, which will enhance friction, which will hopefully increase performance. Now, on top of roughness of ground, we also have to consider, if you're athletics, say a 100-meter sprinter, we have to consider the roughness of contact surface. So in this case, we're looking at what could an athlete, a 100-meter sprinter, do to increase the roughness of their contact surface, therefore increasing their friction. So if you're looking at running spikes, for example, that makes them rough, which increases friction. So please can I ask you to ensure you apply this. Okay, so running spikes are a rough surface, which will increase friction. Okay, now going on from there, what other things, if we move away from athletics now then, often the temperature of surfaces can dictate how much friction there are. So if you think of Formula 1 cars, before they actually start the race, they will do a warm-up lap. And the reason for that is it will increase the temperature of the tyres. So if it increases the temperature of tyres, this will increase the friction, which will give them more grip, which will allow them to perform better. So if you look on here, the racing car tyres have a warm-up lap to increase temperature, which will increase friction. Now, I run out of space here. I'd really appreciate it if you could just add this to it, which will increase friction, which will increase performance. Constantly thinking about that application too, of your knowledge to examples. And then finally, if we have a look at the size of the normal reaction. So how big your, in a sporting action, how big the normal reaction is will dictate how much friction you get. For example, if you're a high jumper pushing into the floor, your reaction force is going to be high. That's supposed to be high jumper, not high humper. So when you push into the floor, that will then give you a reaction force. So in that case, that will provide friction. So if you're in sports that put reaction forces in place, that helps oppose the motion, which will give you good friction in that situation. Okay, so that's those. They are examples for that. So if I can then move on to air resistance now. So when we're talking about air resistance then, air resistance, as I said before, is the force that opposes motion through the air. Okay, so if we look at this then, as you can see, when you're drawing this or describing it, it's really important your start point is the center of mass, and then the direction of travel, can you change that? I hadn't changed that. It travels opposite to the direction of travel. Okay, so that's supposed to be opposite to the direction of travel. So if you could please make sure you change that. Okay, so opposes the motion through the air backwards at that point. Okay, so that's our section there. Now again, what we have to do with this is you might be a cyclist, you might be a sprinter, in which case you would definitely have experienced air resistance. Okay, so what we need to know now is have an understanding of factors that affect our air resistance. So if we are in an activity such as cycling where we want to try and reduce it, there might be certain things we can do. Sometimes it just happens. So one of the factors that affects our air resistance is the velocity of the moving object. So the faster this person is running this way, the more the air resistance going back this way that opposes the motion through the air. Faster a cyclist is going, the further or the bigger the air resistance will be going backwards because it opposes the motion through the air. So I'll put it into here, the greater velocity of a cyclist, the greater the air resistance. Okay, so the faster they are moving, or the greater the rate of change of displacement, the faster they are moving, the greater the air resistance going backwards. Going on from there, the shape of an object can also may have a big effect on air resistance. So you often see cyclists, and when a cyclist, they would wear a certain type of helmet. So for example, a teardrop helmet, and this can help reduce air resistance, which can help increase their speed. So for example, a teardrop helmet, you can see here's a teardrop shape there. So by this, by streamlining the helmet, it can help reduce air resistance, can help them travel faster, increase their velocity. So on top of that, frontal cross-section area is a key factor that affects air resistance. So what we know is that, by what I'm sure you can imagine, the bigger the frontal cross-sectional area, the greater the air resistance. So what people tend to do is try to narrow their position. So for example, a cyclist will narrow their body position in order to reduce air resistance. Okay, so the bigger the frontal cross-section area, the bigger the air resistance, okay, or the greater. And then that's why cyclists will narrow that body position to reduce it. Okay, and then finally the smoothness of surface. So as you can see here, if we use the cyclist again, you can see in this situation what they're wearing. So a cyclist may wear a lycra suit to reduce air resistance. Okay, so they could wear this on top, and that can help them reduce air resistance. Now if we go on from here then, the final thing we have to be able to do is as follows. Okay, we need to have an understanding then of, now we know the four forces in isolation, so we know the two vertical, two horizontal forces. What we have to do now is have an understanding of something called net force, which will then allow us to understand something called a balanced and an unbalanced force. So if I go onto here then, this is our top heading. So first thing, you need to have an understanding of what net force is. So net force, before we actually give you the definition of that, so objects or sports performances, for example, can have more than two forces acting on them at any time. So for example, gravity, reaction forces, frictional air resistance, a number of those could be acting on a body at any point. Okay, so what we need to know then is as follows. What is net force? Now net force refers to the sum of all forces combined. Okay, so that is the key definition. So it's the sum of all forces combined. Now when we know that, we then need to be able to apply it. So what does that mean? So if you have a net force of 0, okay, the forces acting are balanced, okay, which means there is going to be no change in movement. Now that might be that it's stationary, or it might mean if you're already at a velocity, you stay at a constant or uniform velocity. So if the net force is 0, the forces acting are balanced. So for example, as you can see here, if you look at a rugby scrum there, so it might be if the net force is 0 here because the sum of all forces are 0, they're balanced, that force is equal to this force, net force 0, balanced, there's no change in movement, they're just stuck in that position. Okay, so that's why an example of that, we also have to apply net force to when net force isn't 0, or there is a net force present, or unbalanced, I suppose. So if a net force is present, whether that's positive or negative, forces are unbalanced, okay, which will lead to movement. So that could be acceleration or deceleration. So that's 3 ways you could apply the concept of net force. What is it? This refers to the sum of all forces combined, and then the application of net force, net force 0, net force present, okay, and then talking about what that means with regard to movement. Now if you understand this slide, it's really simple to move on, because you could get marks for applying net force and talking a bit about balanced and unbalanced forces, but you could also get direct questions on balanced and unbalanced forces. So when it comes to balanced forces then, okay, so as you can see here, what we've said, so a balanced force basically refers to when two opposing forces are equal. So as you can see here, the force of weight coming down here and reaction are equal. So because those two opposing forces, you might want to just make a note of that. So in this case, reaction and weight are equal in a handstand. That means there is no change in motion or movement. Okay, and then if you go on from there, it could mean that rest occurs, or it could mean that if you're at the same speed, it's going to stay. If you're at a speed, it's going to stay at uniform velocity. But the key things you'll be looking at are the top two there, or if you want to apply that one as well, you can. Okay, so going on from there, then our final thing to have a look at then, hopefully by using this, if we know a balanced force is when two opposing forces are equal, no change in motion or movement, or you have constant or uniform velocity. Let's have a look at the opposite then. So an unbalanced force then, okay, this is when two opposing forces are unequal. So in this case, if we have a look at it, this will cause a change in motion or movement. So in this case, you would have a reaction force that is bigger than weight. Okay, so this causes an acceleration to take place, which would cause them to jump up on here. So you would have, just so you can see it over here, so in this case the reaction force will be higher, greater than weight, so that arrow will go up further, which causes the reaction force to allow them to jump up here to allow them to accelerate and get over the top of the high jump pole. Okay, so you can see that in action. Please make good notes on this. It's a long one, but as you can see, the questions, I mean, it's really set up nicely for you. You're either going to have to describe or draw one of the four external forces. You might get a nice easy one on factors affecting air resistance or friction, or you're going to get something on net force, balanced or unbalanced forces. Easy to interpret questions with just a fair bit of content. Okay, thanks very much.